Hello, and welcome to Owens Corning's presentation of industrial mineral wool versus perlite insulation. Before we get started, let's talk about Owens Corning very quickly. Owens Corning has sales of $7.2 billion in revenue in 2019 and employs 19,000 employees in 33 countries around the world. Also, Owens Corning has 65 consecutive years as a Fortune 500 company, serving residential, commercial, and industrial markets. Our agenda for today is the discussion around mineral wool product offerings as well as perlite datasheet claims. We'll do a product comparison overview looking at thermal, moisture, corrosion, and acoustic aspects of the product, as well as shipping, handling, and compressive strength, and as well as covering some additional resources at the end of this presentation. So to start off with, Owens Corning Industrial Mineral Wool consists of three products. Starting with our Thermofiber Pro Section WR, which is water resistant. It comes in 4-foot lengths for improved productivity and also is ISO 15665 compliant for industrial acoustics. This product is commonly used for piping that you might see in a combined cycle power plant or as used in a refinery. Next, we go to our Thermofiber Industrial Board product, which is available in densities of 4 to 15 pound per cubic foot. These products are easily fabricated for multiple applications, including pipe and tank wrap, and this is the type of tank wrap where you have the cut sections that are actually perpendicular to the facing, so it's more of like a lamella type product. Typically the products by themselves are used for flat work that you might see in a boiler, an old coal-fired power plant, and possibly in a tank construction, where in the tank walls you would use the lower density products, and on the tank top that you use a higher density product due to its compressive resistance. And then finally we have our Thermofiber Industrial Wrap, which is available in 1.5, 2-inch, and 3-inch thicknesses. This product is also ISO 15665 compliant if you need it for an acoustic application. And this is used for large diameter piping. It can also be used for tanks, pressure vessels, as well as columns. The nice thing about the product is when you use it, you don't have as many gaps or joints, or it requires as many fasteners as you would if you were going to be using a smaller dimensioned product for those applications. Regardless of what your application is, we have a product for your high temperature needs. When we talk about expanded perlite, it's a material that it's basically a silica-like material that's run through an expander, and then it's adhered together with a sodium silicate type of binder that holds the product together. This makes the product naturally water resistant, and because of that, use a sodium silicate to bind that together. That also acts as a corrosion inhibitor. It also claims to have virtually no chloride or no lime within the product. It has a high compressive strength of 70 psi, so it's on the higher side of some of those products that are available for industrial insulation. And it's also non-combustible, so it doesn't burn or ignite. And that's a huge benefit, particularly in a high temperature application. So when we talk about product testing and with regards to industrial requirements, we find that mineral wool, of course, meets those requirements, as does perlite. The advantages to mineral wool is that it does meet the ASTM requirements for industrial application. It's breathable and dries out quickly if it does become wet. It doesn't absorb moisture like other material types. Perlite, for example, even though it's water repellent, above a certain temperature, that water repellency is burned off or oxidized. It's no longer as water resistant as it was. And so even though the outside of the insulation might still be water resistant, that inner portion where the binder burns off, it wouldn't be water repellent. Mineral wool has a very low moisture content. So typically it's on the order of around 2%, even though ASTM requirements allow as high as 5% in really high temperature, high humidity conditions. And finally, mineral wool has a very low weight, so it only has about 8 pounds per cubic foot compared with perlite, which is going to have something along the lines of a 15 pound per cubic foot density, so it's almost half the weight. So if you look over here with regard to moisture, one of the ways that you test mineral wool, one is the water vapor absorption test that I just mentioned. The other one is water wicking, where you're actually putting the product into a water bath, and we'll talk about this in a little more in detail later. But you're looking at how much water wicks up into the material. Something like perlite, the way it's evaluated for moisture is, if you look on the bottom item on the table that's on the top right-hand corner, you see there's a submergence specification. So, and we'll talk about that a little bit more in detail. Also, Perlite does have some initial moisture content as supplied, and it's typically around 10%. So as we go to the lower right-hand portion of this slide, we see that we have different ASTM test methods. And of course, we're going to have a thermal requirement or a thermal test because this is insulation. That's what it does. It has to meet a maximum temperature performance. Also have to look at linear shrinkage so we know how much the product's going to shrink or expand after it's installed. And then finally, we're always going to look at something like flame spread and smoke development, because we don't want a product that's going to help facilitate any kind of fires or anything like that in the event something like that happens, it's a higher probability at a high temperature facility where you see temperatures up to 1200 degrees Fahrenheit. And then finally, looking at non-combustibility, this is something that isn't generally required of all material types. However, you will see on mineral data sheets, particularly the Owens Corning data sheet for our mineral products, that they meet the C136 non-combustibility test. And again, that's important in a facility where you're going to have combustible material or there's the potential for a fire. So if we take a look at comparing mineral wool pipe or mineral wool board with expanded perlite, this gives a real good visual representation that in most cases the mineral wool products are going to have better performance than an expanded perlite product of the same dimensions and same application. Probably the big things here are, and we'll go through all these individually, but mineral wool pipe has better thermal performance, good moisture resistance, good corrosion performance, and of course there's some cost and shipping and handling things in here as well. We'll go through this bit by bit, but also want to point out that mineral wool offers the better overall performance compared to expanded perlite. So to start off with, because this is insulation, we're concerned with how it's going to perform as far as resisting heat flow, going from a hot side process temperature piece of equipment to regular ambient condition. So what we want to look at is the thermal conductivity, and essentially the lower the line, the less heat loss through a material in a given period of time. So in other words, the lower the line, the better the performance. Now, just kind of looking at numbers, if you want to look over in the far left-hand side, you can see at 100 degrees, the K value is 0.2 for mineral wool, just a little bit above it. And you see for expanded perlite, it's slightly above 0.4. So roughly, mineral wool has the same performance at half the thickness, or if you're looking at the same thickness for both materials, mineral wool performs twice as well as expanded perlite does. What that really means is better thermal performance means lower heat loss, less energy usage, and you don't need as much thickness of insulation for a given performance requirement. So in other words, you don't need as much thickness of mineral wool as you do with perlite. So again, better thermal performance, lower heat loss at a given thickness. We talked a little bit about moisture resistance earlier, and to go into a little more detail, one of the ways that how mineral wool and perlite are alike is that they both repel water. Moisture content for mineral wool is usually less than 2%, although it's allowed up to 5% according to ASTM. Our pipe sections are tested in the EN 13472 test, which basically means we're putting this insulation in a water bath, and over 24 hours we're measuring how much water that pipe section will pick up. Our products, or mineral wool products in general, will be less than 1 kilogram per square meter. Owens Corning's WR pipe sections are going to be less than or equal to 0.1 kilogram per square meter or 0.2 pounds per square foot, which is really low. Now, looking at perlite on the right-hand side of the slide, again, the moisture content as delivered can be up to 10%. There's also the submersion test that we talked about, and this is a requirement for the standard specification for perlite, which is ASTM C610, and that allows up to a 50% weight gain after the product's been conditioned at a higher temperature for up to 48 hours. Generally, it's water resistant, but after it's been heated, it does lose its water repellency. But the takeaway here is that mineral wool resists moisture, and the reason we want to keep moisture out of our system is moisture degrades thermal performance, because something that's wet doesn't insulate as well as something that's dry. And the worst thing is when you introduce water into this system, that's when you increase the potential for corrosion. So that's a situation that we want to avoid. So one of the ways that we're looking at the reason that we care about moisture is because of corrosion. So we want to use a strategy for keeping water out of the system. And so Perlite and mineral wool, they both use a similar one where we're using water repellency just to keep the water out of the system to begin with, which is the best way to do it. What the Perlite product does in addition to water repellency is that it has a corrosion inhibitor in it, so that if any water does happen to leach through the insulation, it's actually, that water is removed of all corrosive materials, typically chlorides, before it reaches the pipe surface, which is good, except the problem is now we have wet insulation. And again, that inner core where it's red, that might have that hydrophobic agent burn off. So now we're going to have something there that actually absorbs water. The other part of that too is if you have an environment where you have any flooding, that water could completely bypass the insulation and leak right in between that pipe and the insulation in that annular space that's indicated with the arrow that identifies the hot, humid conditions. So again, we don't want to rely on a corrosion inhibitor. We really want to keep the water out in the first place. Now we talk about acoustics. There are several different options that are available with mineral wool. And in this case, as we saw earlier, we could either use pipe sections, or we could use the pipe and tank wrap, which is unique to Owens Corning. Most companies will just have their pipe sections that will have been tested to that acoustic test method, ISO 15665. But just looking through here, there's 4 different performance levels. The performance level A, B2, C2, and D2. You can see that as you progress through the alphabet, you're increasing insulation thickness, and you're also adding mass-loaded vinyl and of course jacketing is going to be present in all 3 of these situations. Sometimes instead of adding a single mass layer, you might also add heavier jacketing as well, although it might be a little harder to work, but that is a way to treat things acoustically. However, Owens Corning has a wide variety of acoustic solutions for this type of testing. Now with Perlite, there is no solution. It's a rigid product, so it tends to conduct sound quite readily from the pipe through to the jacketing. So Perlite does not provide that acoustic function. Now when we talk about shipping and handling and comparing mineral wool versus Perlite, one of the things that we have to take into account is we want to get the product from point A to point B in one piece. Now with mineral wool, because it's resilient and it's light in weight, it tends to travel quite well. The edges stay sharp, the ends don't bunch up unless the product has been mishandled somewhere along the point of delivery. So as such, there are no types of tests that are required to ensure that doesn't happen. Perlite, on the other hand, because of its fragile and brittle nature, does have a tumbling test that is part of the ASTM requirement for this material type. What they'll do is cut up little squares of perlite and put them in with these cubes of oak, and they tumble it in this box at 60 RPM for 10 minutes. And what they're doing is trying to duplicate that happens to the product as it's being transported from point A to point B. Now, surprisingly, the ASTM test allows, or the standard specification for Perlite allows, that up to 70% material loss after 10 minutes. So that basically means if you started out with a pound of material at the beginning of that 10 minutes, you're allowed to have 1/3 of a pound left after that test has been run, which really means you have 70% of material that's dust, and that's going to be chipped corners, edges, nuisance dust, essentially material that you can't use. In many cases, you might have to ship additional material to compensate for that breakage as it's damaged from point A to point B. The nice thing about mineral wool is it resists breaking down during transport, handling, and installation. That's a huge point when you're trying to put together a good system. So when we talk about installed performance, and this kind of fits into what we just talked about, the advantage of mineral wool, because of its resiliency, makes it easier to provide superior installed performance. Because it is resilient, you can get much tighter joints because you can press it a little bit at the edges to close up any gaps that there might be. There's little to no dusting and no cleanup required with the product. Very low shrinkage, so it only has less than 1%. Something with expanded perlite, it generally has a requirement of 2%, but it allows up to 8% shrinkage in thickness, and that can be substantial if you're talking about thermal performance. So there's a potential to underspec things, particularly if you have a lower density or a out of spec product. The potential for gaps with mineral wool, there's hinge sections up to 7 inches, so that means that there's only one longitudinal joint on that system using that size. Going above that, you're only going to have 2 longitudinal joints as you do that. If you go even higher than that, you're going to be using a pipe and tank wrap. Something like an expanded perlite, if again, you have to make sure that those 2 surfaces mate perfectly. And again, if you're seeing a lot of abrading or breakage during shipment, it's a lot harder to make sure you're maintaining that thickness and getting a tight fit. As far as ease of installation for large diameters, pipe wrap works really well. Now with something like expanded perlite, you might have to use heavy and cumbersome quad sections, which are hard to install. So the pipe and tank wrap is much easier to use. As far as the potential for cracks, mineral wool doesn't crack because it's a fibrous product, but something like expanded perlite, again, because of its fragile nature, higher likelihood that you're going to have some breakage or at a minimum cracks, which create all kinds of things. So it maybe as the product shrinks, that makes that gap larger, or cracks are going to form as the product on one side is hotter than the other side, and you get cracks there. So that's part of the reason that mineral wool performs so well thermally. And again, we talked about the density being lower, so it's much easier to handle and install. And then fabrication tools. When you can fabricate something with a knife, you get a much better fit and finish than you do if you're trying to do it with a saw. So it's a much faster and easier application. So again, the mineral wool, because of its resiliency and low shrinkage, provides a much better installed application. Your perlite, because of its rigidity, is a little less flexible and much harder to get a good fit and a good installation. So we talked a little bit about compressive strength, and that's one of the claimed benefits of expanded perlite insulation. And the way that is tested is you use an Instron machine, and we see this on the left-hand side of the screen. So you see those 2 plates, and you'll put the sample between those plates. You move those plates together until it makes contact with the insulation sample. Now, there's kind of a swivel joint on there so that it makes sure that the force is evenly applied. And the advantage of testing in a lab is you can test at a slower plate speed, so that actually makes that load come in at a much slower rate, so you can actually get higher numbers when you do that versus having something moves quickly. You have really good plate alignment, so that the force is evenly distributed, and it's kind of optimal from a test standpoint. But the one thing that doesn't take into account are things like impacts, like if you're walking on something or if you're tapping on it with something, it doesn't take that into account. So if we kind of look at some real-world examples of what we might encounter, I always think of glass, which has very high compressive strength, 150,000 pounds per square inch of force. But I think we all know that it's not too hard to break glass, damage it. And kind of looking at perlite insulation, that's the center picture here. You can see that we have some cracking there, but that product is rated to 80 to 100 psi. This is cracking that happening during shipment, and so this is not uncommon. And then if you're looking at like a calcium silicate product, which also has really high compressive strength, 100 to 125 psi, you can also see that there's been some deterioration as it shrinks, and a product that's actually been in service could have considerably less compressive strength than a product that hasn't been cycled yet. Now, the takeaway here is that just because something has a really high compressive strength doesn't necessarily mean that it adds durability or that it's indestructible. Products can have really high compressive strength, but still be pretty fragile, as we've seen with these examples here. So the final thing is, I think sometimes the tendency is to spec high compressive strength insulation so that we can use thinner jacketing. But really, jacketing is meant to protect the insulation. The insulation is meant to insulate, not to be a structural component of the system. So again, an insulation system is a system, so each part has to do its job. So as we move along and talk about cracking and crumbling, these are some images that were taken from a YouTube video. And what you can see here is this is some of the cracking that can occur when the product is shipped. One thing I would point out over in the right-hand image, you can see where some of the surface has been abraded and there's some uneven surfaces there. So that could have happened during shipment, and so that's the reason why they have that test. And a lot of times they have to have this product packaged in plastic kind of help hold it together and to also keep it from rubbing against adjacent pieces in the box. So this is a real challenge that product has with regards to shipping. Now, to kind of come back to what we already started with, again, having covered all these points, we can see that there's a very good case for mineral wool, pipe, and board products when you compare them with expanded perlite. So again, we have the performance improvements, whether it's thermal, moisture, corrosion, or installed performance. Mineral wool that's important, and mineral wool scores really well in those aspects. On some of the other things that may or may not be important, such as acoustics, shipping and handling, or cost or compressive strength, again, there's another good story to tell there too. So mineral wool is certainly a great option for these applications. Of course, Owens Corning has many resources available. There's always our website where we have product information as well as application guides and books to help use and select our products. We also have an Owens Corning version of 3E Plus in case you want to look at how our products are going to perform in a given application. Our products are already preloaded into that software, and it's free. So I'd recommend that you look into that. And to kind of summarize what we've talked about, mineral wool is proven and tried and true material. It's been around for many years. It's reliable and low shrinkage. It can go to high temperatures. The Owens Corning mineral wool meets or exceeds the industry specifications and requirements, and certainly has best-in-class water repellency when compared to other products that are out there. And we have a wide selection of acoustic solutions as well. And again, there's a commitment to mineral wool that Owens Corning has. There's a state-of-the-art facility that's built in Joplin, Missouri that makes our industrial board products. And of course, the Thermofiber name has been known in the United States for years for their commercial offerings, and they do a fantastic job there as well. So with that, we go to our last slide. If you have any questions, I would suggest you email us at gettech@owenscorning.com. My name is Doug Fast. It's been a pleasure talking to you today. Be good and be well, and we look forward to hearing from you soon. Thank you and have a good day.